8,000 to 12,000 casting cycles. That is how long a single nitride-bonded silicon carbide riser tube delivers molten aluminum from a sealed holding furnace upward into automotive wheel molds at 750 degrees Celsius and 0.1 megapascal pneumatic pressure. Without tumor formation, without contamination, without replacement. 4 engineering properties anchor low-pressure die casting duty. Service temperature reaches 1,400 degrees Celsius. Comfortably above aluminum casting temperature at 750 with a margin of 650. The nitride-bonded matrix is non-wetting to molten aluminum, so the metal does not stick, does not form tumors, and does not contaminate the bore. The dense ceramic structure holds gas-tight seal at 0.1 megapascal across every casting cycle. And the tube survives above 8,000 thermal cycles in continuous wheel casting, against 200 to 500 for cast iron. The tube is produced from silicon carbide grain bonded by a silicon nitride matrix, sintered in nitrogen atmosphere at over 1,400 degrees Celsius. The hard silicon carbide grain delivers wear resistance and thermal stability. The silicon nitride bonding phase delivers the thermal shock tolerance and non-wetting surface chemistry that distinguish nitride-bonded silicon carbide from reaction-bonded or sintered silicon carbide variants for molten aluminum service. The dense matrix forms a protective oxide film during operation that prevents further oxidation through service. Riser tube length, outer diameter, bore diameter, and flange seat geometry are machined from low-pressure die casting machine drawings. Every LPDC machine model, every wheel size, every alloy chemistry combination requires its own riser tube specification. Standard length ranges from 600 to 1,500 mm depending on holding furnace depth and machine geometry. Anti-slag coatings and protective surface treatments are applied to the wetted bore for high-volume wheel production lines. Inside a low-pressure die casting machine, the nitride-bonded silicon carbide riser tube sits vertical, with its flange seated against the sealed holding furnace flange above and its open bore submerged in molten aluminum at 750 degrees Celsius below. When the machine fires, pneumatic pressure builds in the furnace headspace at 0.05 to 0.1 megapascal, pushing molten aluminum upward through the tube bore and into the closed wheel mold. 3 things determine whether the cycle delivers production economics over the tube's service life. First, the bore stays smooth. Nitride-bonded silicon carbide's non-wetting surface chemistry prevents aluminum carbide tumour formation that plugs cast iron tubes within a few hundred cycles. Second, the seal stays gas-tight. The dense matrix and precision ground flange seat hold 0.1 megapascal pressure across the full cycle without leakage, preserving casting cycle precision. And third, the tube survives the thermal duty. Combined thermal shock resistance, oxidation resistance, and corrosion resistance to molten aluminum deliver 8,000 to 12,000 cycle service life, a 20 to 40 times advantage over cast iron alternatives. Together, these properties make nitride-bonded silicon carbide riser tubes the standard component in every aluminum wheel LPDC line worldwide.